So we continue with our discussion of differentiation rules with the rule for quotients of functions, which is called the quotient rule. Okay, so the question is, supposing that you have functions u and v, which are differentiable at x, with a v of x not equal to 0, and you take the quotient y equals u divided by v. So what should be the derivative of y at x? Okay. Now we could go and we could use the limit definition of derivative to do this if we wanted to. But since we've already done the rules for products and the rules for reciprocal functions, so now we can just apply those two rules to get the quotient rule. So y is equal to u divided by v. That's the same as y times the reciprocal of v. So it's the product of u times the product of 1 over v, and we know how to take the derivative of 1 over v given the derivative of v. So using the product rule, the derivative of y is u times the derivative of 1 over v, which is minus the derivative of v divided by v squared, plus the derivative of u times 1 over v. Now we could leave it like this if we wanted to, but if we want to put it over a common denominator of v squared, I can multiply the second summand by v over v, and then I will get that the derivative of y is equal to derivative of u times v minus u times the derivative of v over v squared. And once again, v of x cannot be 0. Okay, so here's an example. Supposing I have a function y is equal to 1 plus 2x over 1 minus 2x. Okay, so this would be the derivative of the numerator, 1 plus 2x, which is 2, times the denominator, which is 1 minus 2x, minus the numerator, 1 plus 2x, times the derivative of the denominator, which is 1 minus 2x, so the derivative is minus 2, divided by the denominator, 1 minus 2x squared, and that simplifies to 4 over 1 minus 2x squared for x not equal to 1/2. Okay, now if we wanted to linearize that function at, say, when x is equal to 1, then y of 1 is 1 plus 2 times 1 over 1 minus 2 times 1, which is minus 3. And the derivative is 4 over 1 minus 2 times 1 squared, which is equal to 4. So then the linearization is given by L of x is equal to y of 1 plus the derivative of y of 1 times x minus 1. Y of 1 was minus 3, and the derivative of y at 1 was 4. So the linearization is minus 3 plus 4 times x minus 1, which is equal to 4x minus 7. In the next session, we will cover the derivatives for the composition of functions.